Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 13, C++. Take it away, Jason.
Hey man, so I had some friends over, some friends of the family over from Florida visiting the San Francisco area. It was pretty fun. I got to show them around. We went to the Monterey Bay Aquarium, and then we went to San Francisco proper, I guess you'd say, and I showed them have you seen that really old vintage arcade museum in San Francisco?
I saw you post pictures of it. It looked pretty cool, but no, before that I haven't seen it.
Yeah, so folks at home, check out my G Plus page, and you'll see an original Pong, which is pretty awesome, and some other really cool, old school, we're talking 1920s or something, arcades. They actually have a bunch of these manual arcades where everything's driven by servos and all that.
I would love to get one of those in my house.
Oh, it'd be awesome. They had one that was a real BB gun that shot BBs, and you had to hit real targets that moved around. It was crazy.
Bad idea.
Yeah, I mean, it shot of course, low velocity or whatever, but
okay,
pretty epic.
Still.
Right. Yeah, but one of the interesting things. So I have a tablet. I think I have a Motorola Zoom. And so I was kind of playing music in the kitchen with the tablet. And, my friend from Florida was like, I really want to get a tablet. I'm kind of really, my techie side really wants a tablet, but I have no use case for it. And, I started, I bought a tablet, so I feel like I need to argue on the, the other side of this. So I was like, yeah, but, you can play music. I play music in the kitchen. And he's like, well, I could just play music on my laptop. I can carry my laptop from one room to the other. And it was really hard. I thought about it and I was like, yeah, I bought this tablet and I really don't do a whole lot with it. So I don't know. It really made me think about how I can sort of
Wait, so
better
not only did you
it.
not convince him to buy a tablet, he made you feel bad for owning one?
Yeah, pretty much.
Wow.
The only thing I really had was that I watch movies in bed, before I go to sleep. And, it's kind of cumbersome to, do that, with a laptop. You could hold a tablet up in the air. For half an hour
I don't have a Motorola Zoom, but I have an iPad. And I will say that although it might be hard to come up with specific use cases, I have, a backup system on my computers that, automatically backs up to the cloud or whatever, just, for safety reasons. And it sends me an email when a computer isn't backed up in a certain time frame. And I keep getting emails from my laptop because I literally do not turn my laptop on maybe once every other week.
Oh, wow.
I don't use it anymore. And the reason being is that, well, first of all, if you have a young child like I have, a baby, that when you're feeding the baby or holding the baby, you can't hold a laptop, or you don't want to risk the baby fluids coming onto your laptop. Yeah. And plus it just being cumbersome, but you can hold a tablet and use it while you're having to hold the baby or feed the baby or whatever. So that's one good use. Another use I found is that if I'm doing casual web browsing, it's a much better experience to do that on a tablet than on sitting in front of a computer or a laptop where you're not needing to use the keyboard. So why is it there? And you're having to use this weird touchpad or a mouse. And it's not I find myself sometimes tapping on my monitor by accident. And it's why is this not working? And so I find that it's useful. It's one of those things is not necessary. It doesn't give me any capability really that I didn't have before, but it's such a better user experience. I can take it from room to room. The battery on my iPad lasts an entire day of light usage. Versus my laptop will hardly last a couple hours, normally 3 hours.
That's
maybe.
True. I didn't think about that, but yeah, I mean the Zoom lasts forever. I don't even plug it in. I basically, when the charge gets low, I plug it in, but I mean that's after weeks.
Yeah, and for a laptop, I find I almost always use it plugged in because the battery just tends to run down so quickly. Yep. And I'm sure there are nice laptops which don't do that, but not mine and not most people I know.
Yeah.
And so that's a really good experience. Also, a tablet, if you're going on a car trip, it's very easy to just pick up your tablet and use it in the back of a car. And it's kind of designed for this pick up, put down. So like you can just put it to sleep, and it's instant turn back on. Versus a computer, you can't just like set it there for like half an hour and then pick it back up because you had a conversation. Because you either would have shut it down, suspended it, hibernated, like whatever. But it'll take 30 seconds to come back on, and that's annoying.
Yeah, that's true. I did one of the most recent times where I used my tablet heavily was I went on a ski bus trip, and there's this program which will let you use a Wiimote to control your like to talk to your tablet. So I actually had like Nintendo games running on the tablet, and the Wiimote was the controller. So
Oh, that's pretty cool.
yeah, it was pretty awesome. I was actually amazed that worked at all because I kind of like I had the idea, and I was like, oh, let me just see if there's some program like that'll let me use the Wiimote on the market. So I just went on market and looked up, which I guess now is called Google Play. I
Yeah.
went on Google Play and looked up Wiimote, and sure enough, someone had written some driver for it. So
Nice.
yeah.
So yeah, I mean, tablets I feel are very, like when I go on a vacation now, I'm not stressed that I need to bring my laptop with me so that I'll have connection to the internet. I'll
Although
just bring my
that's true,
my
but
tablet.
one time I got burned by that. Like when we went to Vegas, and the room only had wired internet, and we're so used to Wi-Fi that we only brought the tablet, and we were kind of out of
Yeah.
internet the whole trip.
So the way around this is that if you know this in advance, which you can typically look it up, and once you have one, you have it, for you don't need to keep buying it again. But they have like travel vacation routers. So it's like either they have some that are even battery powered, but they also have ones that are really small, which are just a very basic, just supports a few connections. That's like $30 or $40 or whatever.
What,
And
really?
you can plug it into the wall. Yeah, run it. It's like a travel router is what it is
That's
for this
amazing.
very purpose.
Oh,
Because the
that's
other
such
thing
a
is
good
if you
idea.
go to a hotel and there's a Wi-Fi and you pay to get on the Wi-Fi, some whatever outrageous rate they tend to charge, and the nicer the hotel, the more they charge,
Yeah.
which is terrible. And so you can use this, pay for just the wired, plug this in, and then broadcast it, and then everybody traveling with you can share it. Versus if they only have Wi-Fi or you pay to use Wi-Fi, you're stuck only using, because it's like tied to your MAC address typically. So you only can use it on
Yeah.
whatever device you paid for it on.
Is it pretty small? Do they make pretty small ones?
Yeah, yeah. I mean, I don't have I don't actually own one, but I know people who do. And the ones I'm thinking of are like maybe a couple packs of card size.
Wow. Oh yeah, I
So,
totally have to get one of these.
okay. I'm
Cool.
costing you money.
I think there's a high
So,
probability that I'm going to get one of these, but for me to know, I'd really have to construct a graph and do a probabilistic graphical model.
oh, okay. You're leading us into our next topic.
Somebody happens to be an
Moving on.
expert on that.
No, 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 no. So we talked last episode about Stanford's online classes, and so I actually was really bad, and I had signed up for them, but I didn't realize signing up, for like interest wasn't enough to like enroll you in the class. So I thought I was enrolled, and then I like got an email like, oh hey, enrollment is ending this day. So I like went to check, and it turned out I wasn't enrolled in a couple of the classes I had picked out.
Oh,
So I was like, no, I had missed the enrollment deadline because they
oh,
try to keep
rough.
everybody kind of starting at the same time because they have forums and stuff, and they want everybody to be around the same part of the class. And so,
Gotcha.
yeah. Anyways, but I'm going through the videos of two of the classes, and I'm not sure that I'll actually do the homework because I've just been really swamped with family and work stuff.
Yeah,
But I have
totally.
been going through the videos of game theory and probabilistic graphical models.
Awesome.
The game theory one is just kind of high level. There's not like programming or anything involved in it. And so that one's kind of interesting class.
Is it under
But the
economics or is it under computer science?
I don't know.
Oh, okay. Yeah, because
So
usually
far
I think I took a
it's
game theory
introduction.
class. I think I took a game theory class in grad school, but it was actually taught by an economics professor.
So this one isn't like game theory, like how to write video games. It's just like the, I guess economics version, the Nash kind of game theory.
Yeah, that's the best
So,
kind.
yeah, it's very intriguing and interesting. And probabilistic graphical models is turning out to be quite interesting as well. There's not an easy way to describe it, and anybody who's not very technical or math oriented would be like, "Why are you taking this for fun?"
Yeah.
but the idea is like, how do you represent like dependencies? So their basic example, just to be short, is like, if you want to predict somebody's grade in a class, like the grade in a class that they're taking is going to be dependent on their intelligence, their SAT score, maybe, how hard the class is, just like various other factors. And so you can kind of draw like a dependency graph. So like maybe SAT is really only dependent on intelligence, and intelligence can also be a factor of what the grade in the class will be. And so then you don't really need it. And you kind of just draw connections between all these different factors. And then you assign weights to the probabilities of various conditionings happening. And you can kind of work out things that at first would seem very, very complex to determine. And I assume it will get even more complicated as it goes, but basically having these models be created by just looking at the data and the algorithms to take data and generate the models.
So when they say probabilistic graphical models, they're not talking about like graphics, like computer graphics. They're talking about like graphs.
No,
is that right?
Graphs. Yeah, like directed acyclical graphs.
Okay, gotcha.
So
gotcha.
Yeah, I got confused at that at first too.
So is this similar to like Bayesian?
Yes, Bayesian networks is a key part of this. Yeah.
Oh, okay,
now that
gotcha.
we just probably like totally people are like, oh man, what are these guys talking
so
about?
basically Bayesian networks or they're also called like deep belief networks. This idea that like if like they try to figure out if like things are correlated, like if one thing can influence another or not. So in other words, like if you tried to see if there was like a Bayesian relationship between like when you flipped a coin the first time and when you flipped a coin the second time, like a deep belief network would tell you like, no, you flipping a coin the second time like is not influenced by flipping it the first time. Like if the first time you flipped it and you got heads, the second time you still have a 50-50 chance, but like something else like weather would have a Bayesian relationship. Like if it rained yesterday, it's probably more likely to rain today than if it didn't rain yesterday. You know what I'm saying? So, so that sounds awesome, man. I mean, I think I might start looking at that class myself. It's pretty awesome.
So it's been pretty interesting. So we'll see how it goes. There's some programming assignments in this one. I want to do them. I'm just not sure that I will do them.
Gotcha. It's hard to do them it's hard to do them on the tablet while holding your baby in the other hand.
Yeah. But one interesting thing that I would like to talk about is that I've done online classes as part of my formal education. But doing them here, it's interesting that you're watching the video. And I normally, people at work think I'm weird, but I do my programming and I'll have one of these videos running in the background. So I'm like half listening to it.
Oh, that's great.
But every so often, they'll interrupt the video with like a quiz question. And it's not like scored or anything. But instead of asking you about something you've just seen to see if you're paying attention, they actually ask you to answer something that they haven't quite covered yet, like the next thing they're about to talk about. Like, so they draw some probability and then say, what would the probability be? And then give you multiple choices. So it makes you like in class, when you're actually sitting there, you're kind of having this interactive, the Socratic method or whatever, right? Like, how would you do this? What would it be? And so they're kind of trying to elicit the same engagement from you. And I thought that was really interesting.
Yeah, that's totally awesome, man. It's killer.
Yeah. And the first couple times I rewound the video, I just went back. I just clicked back. Not like there was an actual rewind. I went back in the video because I thought I wasn't paying attention. And it was like, oh, wait, no, they're asking about something that hasn't occurred yet. So.
Nice. So if you get it wrong then, what happens? Because like it could be
they just tell you why, and then you watch, and they typically explain what the quiz just was. Yeah.
Gotcha.
So I thought that was interesting.
I think if we tried to do some of the programming problems, we'd probably have a lot of trouble. Especially me. I think I'd fail pretty fast. And unfortunately, I just don't really have a way to visualize code so that I can fail faster.
Wow, you're on point today, sir. We have a news story about this. So this is actually by, I guess he's a fairly popular blogger, Jeff Atwood. I think he currently works at Stack Exchange, which is a startup most of our listeners have probably seen before. And he had an article where he's writing about, I guess he actually posted a video that's somebody else about a presentation and then a link to a website. But it was more just the notion I wanted to talk about, which was that he points out that we've kind of almost regressed in the advancedness of our IDEs, so integrated development environments. Mm-hmm. That he's talking about, if we could do better at trying to show programmers the impact of what they're writing, that they could think through the possibilities much more quickly. So that's kind of vague and okay, I don't know what you're talking about. But at a basic level, if you've ever used Eclipse, first time most people use Eclipse, or maybe less so now because other things do it as well, but they draw the squiggly line, like the incorrect spelling under any sort of compilation error that you have in the code. And you can just kind of hover it over and it tells you what the error is, offers suggestions. And this is like a very quick way to actually help you correct the problems. And it's a delight. And
totally.
So that's like at a basic
I'm at the
level.
point now where like I purposely, so for example, like let's say I need to reference something in another file, like rather than like add the statement at the top, this is like include this / my file. I just put what I want in the code. I wait for Eclipse to squiggly line it,
yes.
And then I go over it and I have Eclipse add the line because I'm too lazy to do it myself.
So I'm lazier than that. I just add a bunch and then I do Control-Shift-O, which basically has Eclipse try to guess at what the right imports are and ask you if there's any sort of ambiguity.
That's hilarious. I didn't know that existed.
Yeah, it also deletes anything that you have that isn't being used. So like if you have any imports or includes that aren't being used, it goes ahead and removes them for you.
Oh, that's awesome.
So, so that's like at a basic level. But this, the things that are referenced in this blog article are also even more advanced, which is like if you had like a pathfinding algorithm or a PID, proportional integral differential, a method of controlling something, and you wanted to see how it would be affected based on various input conditions, you could do graphical representations of it, and allow like a person to have a slider and see what would happen as they adjusted various thresholds in their code. Or even better, like, take it up a higher dimension and show them like a plot of, on like XY, here's what various inputs and settings for two different variables will give you. And just like, wouldn't it be cool if we could think about this and kind of try to make our development lives easier by doing this?
Yeah, that's awesome, man. I feel like, like IDEs do a pretty good job about code, but about analyzing code, fixing code, things like that. But like that kind of stuff's actually really hard to do. Like they spend a lot of time because there's lots of customers of Eclipse, right? But for most things like scripting engines for games and things like that, it's just in general, it's just like really hard to do this kind of thing where it's like you're constantly simulating what would happen as you're making code changes and stuff. But I mean, if there's some way we could make that happen, like in a way that was like generic, it'd be amazing.
It's one of the things people talk about for concurrency, that multi-threaded is so hard because it's just too much to keep track of in our brains. And so we, really have to advance the state of the compilers and the development environments to help us with this.
Yeah, it's one of these things that like doesn't seem hard. Like look at just undo, right? I mean, think about undo. Undo, you have to. There's only two ways I can think of, anyways, to implement undo. One is for everything you could possibly do in your program, you have to have another function that undoes it, right? That's pretty hard. And then you have to keep a list of all the things you did. That probably isn't the way most undos are written, right? The other way is that anytime you do anything, you keep like a snapshot, and then undo is just going back through these snapshots, But both of those are hard, One means you have to be able to serialize, which means serialize means turn like a bunch of data that you have in memory or like a bunch of things that you're representing, like turn them into a block of ones and zeros that you can load back later. So you either have to like serialize everything so that you can deserialize it when you do the undo, and then just keep all of these serialized copies of the world around, or you have to, as I said before, create like a reverse function for everything. And I mean, think how hard that is. Like let's say you have a function that deletes a line of code. Well, the reverse function has to, like, you have to have the line of code somewhere so that it can know what you deleted. I mean, that kind of, just adding an undo is pretty hard. And so something like this is really hard, but it'd be totally awesome if if
Oh
we
yeah,
had
I'm
it.
totally not saying it's easy. It's very hard. Yeah,
Yeah, yeah, but it'd be
yeah,
totally
definitely.
sweet if we had something like that. Like imagine, like
It's one of those things that's interesting to think about.
yeah, like you have some kind of game and you're like, oh,
Yeah.
what happens if I like change like the AI behavior? If I make the AI more aggressive and like while you're playing, it's like getting more aggressive. Or what if I change gravity? Or it just does all these crazy things.
Yeah, and I think there are some things that get closer to that. Like, I don't know if you've ever watched any of the demo videos for the Unity game engine, but they have some stuff that's kind of like that, where it allows you to kind of just jump in the game very quickly and see the effects of the changes you've made and then kind of jump back out.
Oh, nice. Yeah, I haven't seen that. That's pretty awesome.
Or maybe I'm making that up. I think I recall that. Okay,
Yeah.
maybe I'll have to send you some videos to prove it. All right, so next article before you lead me into it. There's a lot of news coming out about the next generation of game consoles. The Wii U, I think, is supposed to be out this year or very soon, and
Yep.
the next generation Xbox and PlayStation are supposed to be out. And I don't think the Wii U has had anything about this, but the Xbox and PlayStation have both had these rumors come out that they're going to block the ability to have used games. So either the distribution will be all online, so like think like Steam, or that you'll have these one-use codes, which are becoming more and more common in games for at least some portion of the features, that you have to enter a serial number or some sort of activation code to be able to play the game. And now it's mostly used like to play it online or to unlock some special, in-game thing. But in the future, you could actually just block the game if you don't have this code, and that'll not allow people to sell the games when they're done playing them.
Right, right. Yeah.
So, like, what will happen? What will that do? So, will that make the prices of games lower because now the people are making more money, or will they not sell as many copies because you won't buy a $60 game knowing that you can sell it back for $30 later?
Yeah, it's interesting. I don't really know much about the dynamics of used games. Like I've never actually returned a game. But it makes sense, like it's effectively a waste of money to keep around a game you're never going to play again.
So the way I see it is like, I have an Xbox 360, but I don't think. Oh, for my birthday, I got a game that was new. But aside from that one game, I play only games that are like 2 years old. And I just find like I go and look at the magazines online or whatever and find like what were the best games of 2 years ago, and then I buy them really cheap used. And I have no desire to play the
Yeah,
latest and
makes
greatest
sense.
games. I love playing really awesome old games, and then I can get them for like
Yep.
$5. And I much prefer doing that. And this way won't allow me to do that. But then if you look at something like Steam, I do buy games on Steam, games that are again, like 9 months, a year old, and I can buy them for very, very cheap.
So what you're saying is like if they keep reducing the price over time as the game gets older, then for you as a consumer it's effectively the same. But the difference
Yeah.
is instead of GameStop like getting this like essentially like arbitrage, you're buying it straight from the publisher again, and the person who would have sold the game new can't.
So I don't know exactly what I'm saying, but I do think there is an interest here, like to see what will happen, and like one part of me says like, oh, it's in their ability to ban used game sales if they want, but then the other part of me says it's my freedom, like I should be allowed to sell my game, like I own the game, and I don't really like the idea of we're going to this subscription or license based model, like. You bought this software CD, but you don't own the software. You own permission to rent it for an unlimited time, but only for you. And I don't really like that.
Really, yeah, a lot of people come up with this argument like with music and movies and things like that. Personally, it's never really bothered me. It only bothers me when Steam goes down, and then and it's one of these things. It's so funny, right? Like I could go weeks without playing a video game, but then like Steam goes down, and it's just like instantly, it's like, oh, I really want to play, and I can't. You know what I mean? Like I
Yeah.
don't know. It's like the forbidden fruit, I guess, or something. There's some like psychological thing going on there, but
Well,
but yeah, it's really
I don't.
frustrating when you can't play because it's down.
That's one aspect of it. So always needing to be connected to the internet, or at least often being connected. That's kind of annoying because you could be extended periods of time where you're not,
Yep.
and that would be bad. But the other thing is like I run into occasionally where like I have a computer and then I have my laptop and then my wife has a computer, and I feel like I want my family, like I don't want to give it to other people, but I want my family to be able to share one version of this. And I don't like the idea that I have to keep buying it over and over again
Oh, that's
for what
true.
amounts to like one shared use, because it turns out like we're only ever using one at a time. Like I'm not using it at the same time as my wife, at the same time as, my kids. Like it would only be only one of us using it at the same time, but we want to be able to have it on different computers at the same time.
Yeah.
So like Steam kind of allows that, but like other things don't.
It's pretty BS that like you can't have two instances of Steam running at the same time. So like in other words, like I couldn't play one game and my wife play a different game on the same Steam account at the same time. Like that seems ridiculous, you know what I mean? Like
Yeah.
like not being able
Yeah.
to play the same Steam game, I mean I personally think that's not entirely fair, but I understand how that could be exploited, you know? But if you have 3 games, you should be able to play all 3 of them at the same time.
So wait, so with Steam, if you have the same account, you can't even like own 2 copies of the same game in the account and then like 2 people play them. You have to have
Right,
like a separate account own the second version.
yeah, as soon as you log
Yeah.
into Steam, it kicks you out of all your other instances, like if there are any. Yeah.
Well, speaking about
Maybe you could do
changes
something like offline or something. Sorry.
Oh no, I was gonna transition. That was gonna be you. It's okay. So Prince of Persia, I remember that game. That game was pretty awesome.
Yeah, Prince of Persia definitely no DRM on that. Came out 23 years ago. But did you ever beat that game or get like really far or anything?
No,
That game was
no.
so hard, man. Like we all played it when we were kids, and I don't know anybody who got you. It actually had different themes. Like you started off in the castle, and then you went to like some cave theme supposedly. I think it's. I don't think any of this really
I don't think I ever
exists.
beat the first level.
That's what I'm saying. Like I don't know anybody who got past the second or third level of that game, and it has like supposedly like 20 levels or something like that.
What?
Yeah,
Ah.
it's like there's another game like this. Oh, it's like Frogger. Like, did you know Frogger has like all this complexity? Like after you get past this, like the first level, you have to get all the little frogs in the top, right?
Uh-huh.
Then the next level, the cars move faster, and there's like a snake that goes on the sidewalk before you get to the turtles.
I think I've been there before.
Yeah,
Yeah.
and like it just gets crazier and crazier. The third level has like alligators, and then like the fourth level has like other kind of cars. The fifth level, like it gets to the point where like you have to save your girlfriend frog, and she has to go in the
What?
same hole as you. Yeah,
No.
it gets. I'm serious,
Ah.
dude. You have to watch a video or something. It's crazy. Anyway, so.
Okay, so why we were bringing up
So-
Prince of Persia?
Yeah. So the Prince of Persia, awesome game, came out a long time ago. Maybe we'll go back and play it now that we're older, and we'll still suck at it. But anyways,
I have it on my iPad, but I'm still just as terrible at it.
that's hilarious. So
Yes.
the guy who wrote Prince of Persia lost the source code, and I actually, from the article, I don't think it talks about how he lost it. Let me just scan it really quick. Along the way, he misplaced it. Yeah, so somehow he lost the source code, maybe a hard drive crash, I don't know. And, I guess forever, like, he always kind of wanted to go back and have the original. I'm sure it's been recreated 100 times, but there's a lot to be said for having the original code with the comments
Yeah,
and, like,
yeah.
maybe the jump used to be
Lack
longer
of comments.
and he shrunk the jump speed or something. Like all these, like you see the organic nature of like the game, right? So it turns
Right.
out his father was going through some of his old boxes and found the source code on some floppies, and
Nice.
he's going to he's got somebody who's going to port the game. I'm assuming to SDL or something where we could play it on modern PCs, and then open source the whole thing.
Cool.
So yeah, it's
Cool.
pretty cool. I mean, when they open sourced like Doom and Quake 3 and stuff like that, it's always like, yeah, I'm gonna make my own game, and then you get into it, and it's like the code is such crap. Like you'd be better off buying a game engine, But
Well, let's be polite. Let's be polite. It's a complex game that's very difficult, and the people probably were awesome programmers, but it is very difficult to read not knowing what's going on.
oh yeah, actually, yeah, you're right. We should do this justice. So the code's crap, no, just kidding. But no, but basically, you think about it. Prince of Persia. You look at the video, and we have the link. You can watch a video of the gameplay, and you think, oh, I could hack that up. I could write that in JavaScript or something like an HTML or something. But at the time, this totally pushed the limits. Like having like a panel that fell when you walked on it. It was like, whoa, big deal. Like he had to like write his own memory manager to make that work or whatever, because so because of the for one, the technology being new, like either they were pioneers inventing the technology as they went, or it had just come out. A combination of that and just the limited computational resources, there's just the code is almost always filled with tons and tons of hacks and things like that.
Yeah.
But that in and of itself is interesting to read. So when the source code comes out, we'll definitely revisit this and take a look at what
Okay,
sort of
so you're going to go
craziness.
through it and give us your line by line commentary?
Yeah, I'll dive through the code. Line by maybe I'll do a file by file. It'll probably all be in one file, prince.c or
Next
something.
episode will be Jason reading the code of Prince of Persia to us.
Yeah, exactly.
Bedtime stories with Jason.
Yeah, that'll make myself fall asleep.
Oh no.
Oh,
Are we ready for our tool of the bye week?
tool of the bye week. All right, you go first. What's your tool?
Well, keeping in my theme from last week or 2 weeks ago of completely absolute opposite of tools and instead things that waste your time. This week, not that I've had much time to play it, but I did play a little bit of DC Universe Online, which is a massively multiplayer online role-playing game, and it's free to play now. And
Nice.
I'm a lot of these that are free to play. Like I've tried them a couple times, and they always want you to end up buying something.
Oh, totally.
But this one actually has a lot of like I didn't feel like I don't even know where you were supposed to buy something at. Like I was just playing and it was not a big deal.
Wow.
And so that's really cool. And I didn't get very far, and like I said, I've been pretty busy, so I pretty much just installed it and played around for like an hour or something. But it is really cool. So if you're interested in being some of the cool comic book heroes, check it out, dcuniverseonline.com, and it's free to play now. And as far as I can tell, you can do a lot in the game without needing to pay anything extra.
So how many people do you play with? Like I know it's massively. So there's different kinds of massive multiplayer, right? Like there's Eve
Yeah.
Online where it's like literally like thousands and thousands
One
of people.
universe.
Yeah. And then
Yeah.
there's also like on the other end of it, there's Yahoo Games, which has like 10,000 people playing chess, but you're only playing with one person. You know what I mean?
Right.
Both of those are
So it
considered
depends on.
MMOs, but So where does this fall in that spectrum?
So I don't know that I ever ended up kind of like doing a mission with somebody else, but it kind of depends on the mission. Like there's some stuff you can just kind of go off and do yourself. But
Oh,
then there's
okay.
other stuff where you can be in a party of, probably like 6 or 7 people.
Oh,
I
okay.
don't remember
It's
exactly
not
how many
bad.
it was, but yeah. So it's not, and I mean, sometimes you'll be in an area where there are many, many people, but it's not like you're all doing the same thing together.
Oh, do they have a pretty good character customization?
Yeah.
Because I was playing
So
Star Trek Online, and they gave you like a little bit too much freedom with the character customization, and I'll have to put a screenshot or something, but it's pretty epic. I have this character, and she has they have like a ton of sliders. Like you ever play this game where it's like
Wait. Should we just cut this off before we even go there?
no, it's not. No one's gonna should be
Okay, all
offended
right.
by this. But they have like you play like I think Skyrim has this where it's like they have a slider for your nose and you slide it all the way and you get a huge nose or a tiny nose or slider for your cheekbone height or whatever. Right? All this crazy stuff. So this game was like that, just pages and pages of sliders. And so I made a character that had huge legs, like really, really long legs, and then extremely tiny waist, extremely tiny torso, extremely tiny neck, huge arms, and then a huge head. And so it basically looked like a four-armed octopus. And like because the legs were so big and disproportionate, the character floated. This is on Star Trek Online. The character floated above the ground because it was so glitchy. The character like the legs clipped through each other when the character walked, and the head like clipped through any doorways because the character's like 8 feet tall or something. And the arms were so long that they cut through the legs too, like constantly clipping through. And I played a mission, and literally, like, I'd walk around, like, the hub area, and people would just give me money and laugh at me because my character is so bizarre. Then finally, we did a mission, and at the end of the mission, everybody did some kind of, like, dance or salute or something. and the rig got so thrown off with these proportions that the character actually the arm inverted. Like the
Oh
arm went
no,
inside, like
inside
through the
out.
arm socket and like back out the head or something. It was totally
Oh.
awesome, man. Yeah, my character had like purple skin. It was-
So if you see somebody matching this description online, say hi.
yeah, that's probably me. Oh man. So
All right. So what about your tool of the
my
bye week?
tool of the bye week is sfxr, which is a pretty cool 8-bit sound generator. And a lot of people have used this. If you've ever played the game VVVVV, it's like an indie
Yes.
game, like a platformer, and it looks like it was a
It's
Commodore
a way to die
64
10
game.
times in 3 seconds or
Yeah,
something.
exactly. I think I died. Like they show you your death count at the end of the game. It's just ridiculous, like
Wait,
8,000
you
or
beat the
something.
game?
Yeah, I did eventually.
Ah,
Yeah, because
you made me feel so bad.
you have infinite lives, right? So eventually you'll get
Yes,
to
but
the
I just
end.
kept dying for like an hour.
Yeah, I died for like a week and then the game ended. But,
You've died 1,000 times. Congratulations, you win.
yeah,
Sticking through it.
exactly. But this guy was part of a indie game hackathon where it's like make a game in a day kind of thing, and he had some background in audio, and so he made an 8-bit sound generator, and it's pretty cool. Like you can actually put bullet and it will like click random and it'll make a bunch of random like 8-bit sounds with square and triangle waves that kind of sound like a bullet. Like it's hard. I don't have any background in audio, so I don't really know how to explain it other than to say, there's a bunch of buttons, but not so much that it's overwhelming. And the buttons are pretty intuitive, like angry or something like that. And you just sort of like weld all these adjectives and nouns together, and then click random a bunch of times until you get the kind of sound you want. But it's
Oh,
really
cool.
cool. Yeah, makes some great sounds. Exports to Wave, which then you can put in Audacity and export to OGG or MP3 or whatever. And yeah, definitely if I ever need to make sounds for anything, definitely be using it again. So good stuff.
Well, if you're ever making a game, what programming language would you use?
Well, if I was making a game, I'd want something that had like a lot of performance, so I'd definitely be writing that in C++.
Oh, okay. Well, that was maybe a little bit unfair, but it's a transition to
Yeah.
our programming language of the
It's a
episode,
shame we
C++.
haven't talked about C++ and people just can't make games because, we haven't given them any guidance.
Yeah, I think there's other ways to make games too. But
Yeah, probably.
anyways,
Yeah.
so
Um,
the history of C++. Now, C++ is obviously the plus plus, meaning that it wasn't the first, so there was something before it, and we've talked about that before. That was C.
yep, totally.
And somebody had the idea to kind of make C better, and that person was. Would you care to pronounce?
I'll do my best. I think it's Bjarne Stroustrup. I don't know if that's right or not. I've actually only read the name, so never
Yeah,
actually
me as well.
pronounced it. But
So, yeah, so he, Mr. Strostrup, we're gonna get all sorts of corrections, I'm sure. That's okay.
yeah,
Yeah, he had the idea that he wanted to add classes to C, and so with anything as C was coming out, people were hesitant because they wanted to write everything in assembly, and then as C++ came out, we're gonna have these classes thing. He wanted to be able to show people, look, it really is just kind of like C but better. And
yep,
so the original compiler was actually just to compile C++ to C and then use the existing C compilers to generate machine code.
yep. I mean, if you put yourself in his shoes, like people had been really working on C compilers for a long time, and they were highly optimized and things like that. And you want to invent your own language. If you make your own compiler to assembly, it's not going to be anywhere near as good as C, because they've done so many optimizations. So, as a first step, it makes sense. He wrote the C++ compiler to go to C, and then you can use your highly optimized C compiler. It's sort of like what's going on now with LLVM.
Yes, yes. And I mean, it people eventually, started to come around and say, "Wow, this is nice." But there was the original versions, and you'll still hear if you go to somewhere where people have been programming for a long time, especially performant programs for a long time. A lot of people still have a hesitancy of C++ because they think it's so much more inefficient than C.
Right.
And that just has to do with the idea that those original versions, when you were translating from the C++ to the C, it generated, kind of more C code than a hand-coded C program. Just like a, program written in C generates typically more instructions than a hand-coded assembly program.
Yep. Yeah, totally. I mean, I think that one of the things too is, and we've touched on this before, but just to recap, it's in the end it really comes down to how you use the language. Like for C++, for example, as we mentioned, it's C with classes. If you have, let's say you're doing some kind of like fluid dynamics, right? And so you have a bunch of cells which have, water in them that are moving in a certain direction. Well, if you make a separate class for every cell, and then you try and do some kind of fluid dynamics where you go to all the classes and then in each class you do some like computation, that's going to be way slower than just having an array of floats, right? Or something like that. So like that's an example where like you don't really want to make a class for like everything. You just want an array of floats and then maybe just one class that does like the fluid dynamics for the whole world or whatever, So, in the beginning, with most languages, it's a combination of the language isn't optimized, but then also people don't really know what to do with the language. But then
that's a good point.
over time, people start, the language, as it gets more adoption, people start to understand the best ways to use it.
Now, C++ doesn't have versions like some other languages. Like there's not C++ 1.0, 2.0.
Right.
There's nothing like that.
Yeah,
Yep, go ahead.
Oh, there is a new version coming out, and have you studied this at all?
I did look into it a little, having some background in C++. I was very intrigued, like, oh, they're upgrading, what are they going to add? Like, how are they going to bring this into the, kind of 21st century? And so it was originally, going to be called C++, 0x or whatever, implying that it would come out in the single digits of the 2000s. But they kind of missed that deadline and getting agreement on what they were going to put in. So I think the official name ended up being C++ 11.
I didn't know that.
Coming out in 2011.
I always thought it was C++
Wikipedia
TR1 or something.
Oh. Well, I think that was one of the early versions of the 0x before it got fully ratified or whatever.
Got it.
And so C++ 11, which we haven't talked about all about what C++ has, but they just try to make the language a little easier to use while at the same time keeping it being powerful and try to add some stuff for, the idea of multi-threading and concurrency, which wasn't as big when C++, of course, was in earlier versions. And then just making some things nicer, like kind of inferring what values should be as opposed to having to make them explicit. Or if you have like a constant function, you can create an array by calling that function and, like adding a number to it. So like if you have a function that just returns the number 5, you can make the size of the static array be, calling this function plus 2, and it knows to make it 7. Whereas before that would have been illegal because in C++, the static arrays, have to have a constant size definition.
Gotcha. Yeah, one of the big things that's in the new C++, it's probably not that big, but it's really important for me anyways, because it's good for people who want to develop quickly, is something called a shared pointer. And so what this is as we talked about in the C podcast, C++ and C, most of the time you're dealing with pointers that you allocate. So you say, hey, computer, give me a chunk of memory so that I can do something with it. And usually, in C++, in C, you'll say malloc. In C++, you say new. But they do, like, close to the same thing. And then later on, when you're done with that memory, in C, you would say free, and then the chunk of memory. In C++, you say delete. But it's the same kind of thing. Once you're done with the memory, you have to delete it. Otherwise...
so you're in control of memory management.
Right. So, and if you don't delete the memory, then eventually you will run out of memory because you'll just keep creating asking the
You'll leak it.
computer for memory and not returning it back, right? You'll leak memory. So what shared pointer does is you wrap your new inside the phrase shared pointer, and it knows it knows when to delete it. So basically, it does what's called reference counting. So if you say like shared pointer x equals new int, well now like x points to a reference. Contains a reference saying, hey, right now x is using int, so we got to keep it around. Then later on, if you say y equals x, now there's two references. So like behind the scenes, it's saying, hey, two people, y and x, are both using this integer, so we can't free it. And then eventually your program keeps running, and then just as part of the program, y and x, let's say, fall out of scope. Like maybe they're part of another shared pointer, like they're in a class that is itself contained in a shared pointer, or your program ends, or whatever. It says, hey, there's no more references to this int, so now I can free this int. So it does all the freeing for you. That's one really nice thing that was added in the new C++.
So does that mean they've added garbage collection to C++?
Um, Boy, that's a hard question to answer. I guess technically, so for people, I don't know if we've explained garbage collection.
I think we did a little when we talked about Java, but I'm
Oh,
not
okay.
sure.
Well, we'll explain it just really quick. Garbage collection is the idea that, over time, so some languages like Java, you don't free things, and but because of there's like actually, so no, to answer the question now that I thought about it, no, it doesn't implement garbage collection. And so what that means is, let's say you have shared pointer x that points to some class, and then that class has a shared pointer y that points to x. So you have a loop, right? So x refers to something that has y, and y refers back to something that has x.
Okay.
In Java, the garbage collector will run every now and then, and it'll say, hey, these two things are referring to each other, but nothing refers to them. They're isolated, and there's actually no way to get to x, because there's no way to get to y, and y is the only thing pointing to x. So we're going to delete x and y.
Okay.
That's garbage collection, or that's one part of it. So C++ doesn't do that. So actually, if you have a circular reference and you don't sort of clean it up yourself, then you'll leak memory that way. So that's actually a really good point. Very subtle, but it happens.
Yeah, yeah. So I mean, it is kind of a loose approximation of it in some ways, but some people don't like garbage collection because the idea that, and in Java has gotten better about like allowing you to specify when and how garbage collection will run, but the idea that something's going to run that you don't have control over. And in a lot of uses of C++, people want to have absolute control over everything that's running and when it runs and how it runs.
Right. Like you'll see in a lot of like a lot of games, especially like the critical, graphics or physics loop in a game, they allocate everything up front. So in other words, they create an array like right when the game starts. They create an array for, like, let's say it's NBA Live, some basketball game. They create an array for 30 players, like to include the players on the court and on the bench, right? And for 30 ragdolls in their physics engine. And that's it, And so when the first player gets initialized, like after you pick your team, you pick Philadelphia 76ers or whatever, and it starts initializing players, there's already locations in memory for those ragdolls, and then it just kind of fills in the specifics. But all of the memory gets allocated up front, and that's because, as Patrick's suggesting, like you don't want to be allocating and deallocating memory, while the game is running, because what that means is you have no way of guaranteeing how long something will take. Like if you're writing C++, you're often in an environment where your boss is coming to you and saying, "Look, Patrick, you have 10 milliseconds. Like every cycle you have 10 milliseconds. That's probably a lot. You have 1 millisecond dedicated to like the graphics engine." And so if you ever take more than a millisecond, some red flag's going to go off, right?
The game's going to stutter.
Yeah, that's right.
You're going to get frame drops.
Yep. And so, if you use something like Python or Java or something like that, you run the risk of, oh, every 300 frames or so, the garbage collector kicks off, and now you're hiccuping.
So we got a little ahead of ourselves, maybe somewhat, talking about kind of how C++ is used. But so what are some of the features that C++ has that people like?
Yeah, so these are the big things that, as we mentioned, C++ is used for like really time critical programs and things like that. But you might ask yourself, well, why not use C? Like, what does C++ really bring to the table, right? And one of the biggest things is obviously classes and the things that come with classes, like virtual functions with inheritance. C++ actually has multiple inheritance. Um,
So
different.
wait, what does that mean?
Yeah, so so in in Java we might have talked about this inheritance, but basically, let's say you have a class like let's say you have a class called shape.
Shape.
That's amazing. Okay, so you have shape, and then square and circle both inherit from shape. And shape is an abstract class, which means that shape contains some functions that aren't implemented. And because it's abstract, you can't actually create a shape. So, in C++, you would say abstract class shape, right? And you'd give it a function, let's say area, get area. And get area would be what's called a pure virtual function. So in C++ lingo, pure virtual function means that someone else who's implementing or inheriting this class has to create the get area function because the shape class can't do it. So then you have, say, square, and the square class inherits from shape, and the square class will define get area. So it's like, int get area and then do side times side, right? You'd also have the circle class, and the circle class inherits from shape as well, and its get area function would do what radius times pi, right? Or radius, was it radius squared times pi or something for the area?
Yes. Yes. Pi r squared.
Yeah,
Yes.
that's right. So it's two different classes that have different get area functions, but they both inherit from shape. Then what you can do later on, let's say you're making a physics engine or something, you can have an array of shapes. Even though you can't create a shape directly, you can do what's called downcasting. So you can have an array of shapes, and then you can say, oh, I want to add a square to this array. So I can say like shapes.add new square, shapes.add new circle, shapes.add new square for another square. And then you can go through this list of shapes and get the area for all the shapes, even though you don't necessarily know which one's a square and which one's a circle. You know that both of those have the get area function because they extended or they inherited from shape. So that's kind of in a nutshell inheritance. Now, um, what multiple inheritance means is kind of what the name suggests. You can inherit from multiple things, and this is really useful. So especially, let's say, let me think of an example. Let's say, let's say like a square is a shape, but a square is also something that can be drawn, like a renderable. So you're making a game, you have these square. Let's say you're making like Angry Birds or something, right? So and you have something called circle, which is going to be your Angry Bird. So circle is a renderable, like you want to actually draw, a little bird-shaped circle, but then it's also a shape in the physics sense, like you want it to bounce like a circle. So your class, your Angry Bird class, would inherit shape and inherit circle at the same time.
Okay.
So multiple inheritance actually gives C++ a lot of power.
And Java does try to handle the same thing, but it does it through what's called interfaces. So you can kind of inherit multiple inheritance by inheriting multiple interfaces, but interfaces are restricted in what they can be. And C++ basically allows you to inherit from multiple things which are more complex than just an interface.
Right, exactly.
And then one other comment, I think abstract is a Java term, right? I think in C++ the class just has a function which is defined as virtual and then set equal to 0 to make it an abstract class.
Oh, really? Yeah, I think you might be right. I thought it was.
It's okay.
I've been doing
We
Java for
both
too
done a lot
long.
of C++, but we've both been doing Java recently. So
Yep.
if we get a little sketchy, we're sorry.
I thought that is
Um,
it a virtual class then or no?
it's a virtual class if it has at least one virtual function.
Oh, that's right.
Is that
Yeah,
right?
you're totally right. So yeah, in C++ is just a class. You don't put
Right.
abstract in front. In Java, you put abstract in front.
Yeah.
But
Yeah.
if you, as Patrick said, if you have any virtual functions, and the way you make a virtual function is you put the prototype, like in the case of the shape, you'd put, int get area, and then parentheses. But then instead
Virtual
of,
int.
oh right,
Virtual
yeah,
int get
virtual int
area.
get area in parentheses. But then instead of putting, function there,
A
you would put
body.
equal, right? You'd put equal 0,
Yeah.
and that lets the compiler know that anyone who anyone who extends or anyone who implements this function or this class is going to have to create the get area function.
Yeah, they must override it because you can't come up with a good generic implementation of it.
Right.
Yep. The other thing that C++ allows you to do is something called templating, which a lot of high-level languages allow you to do. But this is basically, instead of having to have, so like in, let's say, get area, you might want to be able to get areas with integers, but maybe also doubles, or maybe, I don't know, like imaginary area. Is that even possible? I don't
Complex
know.
numbers.
Complex number area, I guess, maybe. Anyway, so you might want to have like all these different things, but instead of having to write, if the way it's handled is very similar, then you may not want to have to write like get integer area, get double area, get float area.
Right.
That would be very tedious. So templating allows you to write the function once. If area is just, let's say in the case of just squares and rectangles, width and height, and you're just multiplying together, and it doesn't matter what type they are, then basically it allows you with a special syntax to define like, hey, the person has to specify what type it is when they call this, but I don't care what type it is, or even like I care but only in a certain way, and so that then it's just width times height, and you don't care if those are integers or floats or doubles. It'll just kind of handle it for you.
Right. Yeah, it's really interesting. What the compiler actually does with templates is, it looks at all the times you use the class, and it creates that many copies of the class. So in other words, let's say you had a list, and you had the list class was templated. Then later on in your program, you have a list of integers, and then later on you have a list of shapes, and then later on you have a list of floats, like throughout different places in your program. Well, the compiler will count all those up, and then it'll actually take your list class and create copies of it. So you'll have a float list, you'll have an int list, you'll have a shape list. But it does all this for you like behind the scenes, so you don't have to actually go through all the trouble of duplicating, copying, and pasting all of your own code.
And that is powerful. The reason that it does that allows you to do, which we won't get into because I don't even know if you could describe it in a podcast. It'd be kind of hard verbally, but templated meta programming.
Oh yeah, that's
which are programs that you write that get run at compile time, not at runtime.
Yeah, totally. So there are some things you need to do. Yeah, I'll go real quick over this.
All right, you can try.
There are some things that you need to know at compile time, but you need to use equations. Let's say you have 3 plus 4 in your program. Well, the computer, the compiler doesn't know that that's 7. The compiler, you have to actually run the program, and then your computer, once running the program, will do the 3 plus 4 and then return 7. But there are some things, like some computations, that need to be known at what's called at compile time. So while the compiler is compiling, it needs to know that this 3 plus 4 is 7, or this x plus y is whatever it is. And so to actually do this plus at compile time, you can actually do things like this using what's called, as Patrick mentioned, template metaprogramming. But it's very rare that you have to do something like that, but it does come up.
It's one of those things that's really cool, but if you use it, chances of other people understanding what you're doing are low.
Yeah, exactly.
Something else that C++ adds is operator overloading. So once you define a class, it would be really nice if you could do something, like I want to add 2 of my classes together. Like my classes represent probabilities, and I want to add these 2 probabilities together and have them be added in a way that is unique to the probabilities of my classes that are defined. And so I want to redefine how the plus is, what happens when I say, my shape and then the plus sign, my probability, the plus sign, and then, another instance of my probability. And C++ allows you to do that. So you can still use the plus sign, but it knows to call special code that you wrote to do that operation.
Yeah, totally. And I don't think Java supports that, right?
Oh, you put me on the spot. I'm not sure.
I mean, I know it didn't used to. Now they've been adding a lot of stuff to Java. No, I'm pretty sure. Let me just double check. But I'm
Well, while you
almost
talk about that,
100%
the,
sure.
the one that there's many things that we can continue to talk about. But another one we talk about is that C++ adds exception handling, and this is kind of a controversial topic. Whether or not exception handling is something that should be used or shouldn't be used, how expensive is it, how cheap is it, and everybody's got their kind of thing. But C++, if you want to use exception handling, so throwing and catching exceptions, it does add that capability.
So interestingly enough, I'm really glad I looked this up. So Java, doesn't support operator overloading. So what that means is, and the example they use is there's a class in Java called big integer. And as the name suggests, it can hold an integer of effectively infinite size, right? It'll just keep allocating memory and, as much as it needs to hold any size number. And so to add two big integers, you actually have to say a dot add parentheses b, because you cannot do a plus sign b like you can in C++. But Scala, which is a language derived from Java that we probably should do a podcast on sometime, Scala actually does have operator overloading. So
okay.
That's pretty wild, yeah.
That's cool.
But yeah, C++, as Patrick mentioned, clearly has operator overloading, and it's amazing. So useful.
It is. But it can catch you if you think plus does what a normal plus does and somebody redefined it to be something else. Yeah, that could be dicey.
Oh, that could be rough.
Or they can redefine what the square brackets are. So normally that's like indexing an array, but you use it to mean something else. Yeah, that could be bad.
Yeah, I don't think you should do that. Typically, if you overload an operator, there's this understanding that you're going to do something that's intuitive to everybody. So even if you could, let's say add two graphs together, typically you'll use a function for that, just because you want to have a function with a descriptive name, like maybe like merge graphs with edges or something like that. Like you want to let the person know kind of when you add these two graphs together, what are you really doing? If you do like just an operator, a plus sign for two graphs, then what somebody else thinks adding two graphs is might differ from what you think.
Yeah.
And that can cause drama.
So the strengths of C++, we already kind of started on them, and some of it is that traditionally it's been kind of along with C, kind of the very fastest way to get stuff done, or at least relative to most other programming languages.
Right. Like just to give an example, I actually wrote a NESizer, which is just a name I made up. But basically, it takes pictures, and it does takes the NES, like the old Nintendo palette, like the color palette from Nintendo with like 54 colors or something, and it does like this k-means clustering. It does like way more than it really needs to, but it tries to make the image look like it would if a Nintendo like video game designer drew it. So you could just give it a picture of your face and it'll look like your face like belonged in a Nintendo game. But
awesome.
But yeah, I wrote it in Python, and it takes like probably 10, 15. It probably takes about a minute to run. And to test it became hard to debug because, it'd literally take a minute. I'd find a bug. It'd take a minute. And I rewrote it in C++, and it runs almost instantly.
Now there were probably things you could have done in Python to make it run faster.
Yeah, I could have.
But the idea is that out of the box, the generic way of writing it in Python versus C++, C++ will end up being faster.
Yeah, that's a good point. So Python actually, ironically enough, Python has what's called C types, which adds support for C and C++ like data structures. And I could have used the C types array and stuff. So don't take that as a slam on Python or anything like that. It's not like your code will just, it's not magic or anything like that. But yeah, if you just code normally, your code will typically be much faster on C++.
So another thing is that the object oriented allows for collaboration amongst very large teams in an easy way. So Jason's working on the shape class, and I'm going to inherit from it, and I don't really. Well, that's a bad example. So we both have the shape class, and I'm going to implement square, and he's going to implement circle. And as long as if we have kind of the interfaces between those defined, we can all work at the same time on our own pieces of code, and that's very nice.
Yeah, definitely. I mean, it makes it very easy to write, APIs. And one thing about C++ that a lot of languages don't have, C++ has separate header files and source files. And so the idea is the header file, also called like the .h or the .hpp file, will sort of have a description of what your class looks like. So it'll say, hey, you have this class, it's called Patrick Wheeler. It has this function called get area. But it has these it has these functions. You have this like shape class. It has get area. It has some other thing like get boundaries, get center, or something like that. And then it also, in addition to the .h file, there's a .cc file or .cpp file, depending on what extension you use, but both of them are the same, which actually has the implementation. So if you have some class, let's say it's file reader, the .h file would just show like there's a function called read, there's a function called read line, there's a function called close. But then if you go to the .cc file, you'll see actually what read does and what close does, what read line does. And so this is really nice because you can give people the .h file and they can get an understanding really quickly of what your program does without having to, or like rather what the architecture of your program is, without having to know what each function does. So if you're on like a huge team, and the other thing is the .h files, you might make those like up front and not change them very often. So let's say I'm working on some graphics engine. I can just hack together some .h files. I can say, okay, I know there's going to be a graphics engine and it's going to have a list of shapes. And the shapes, there's going to be a square and a circle, and there'll be some get area functions and some rendering functions. And I'll just send this to Patrick so he has an idea of what I'm going to do. And then he can code to those .h files and he can include them in his code. And then, we can both work in parallel that way. So it's a great way to communicate. The language itself allows you to do things like that.
So some of the weaknesses, we talked about that you have absolute control over the memory. And so it's in a similar way, just in having memory leaks, you can also have memory corruption that, you can overwrite other pieces of code if you're, C++ has a notion of a pointer. So it's this variable holds a memory address, but I can change what the memory address points to. And as long as if my program has permission to write there, I can write whatever I want to that.
Right. Yeah, I mean, a big case where things like this happen is, let's say you have an array, and the array has 10 elements, and you're looping through the array. So you might have a loop that says, like, go from 1 to 10. Like, you might say, at the top, it might say, okay, int size equals whatever the size is. So now my size variable is set to 10. And then I write this for loop that goes from 1 to size. But I never try to recalculate size. I just know it's 10. And I go through this for loop and do some stuff. Well, what if my program's multi-threaded? And while I'm in this for loop, somebody else goes through and deletes like a few elements. Well, now I'm going to go through 1 to 10, but there's only 5 elements. And C++, it won't give you an error or a crash or anything like that. It'll actually just read whatever memory is there. And like this happens, the worst case where this kind of happens, even worse than adding element or removing elements, is you might add an element. So let's say you add the 11th element, and that causes your vector to shift to another location in memory, and you end up with all sorts of crazy stuff where you're reading memory that doesn't make sense, but you're not crashing, you're getting data, it's just bogus. And so these are incredibly hard to debug. And this is why a lot of old school games have these like really esoteric or really like interesting errors. Like, you ever see the -1 world in Mario?
No.
Oh man, you should watch his YouTube video. There's a glitch in Mario, and you can exploit the glitch and actually go to the world -1. There's another bug in Castlevania 2 for Nintendo where you can, and these are both written in C, but the same kind of bugs can happen in C++. Where in Castlevania 2 you can actually fall through the ground at like a very specific spot, and you're in like random memory in the game. And so like effectively like some percentage just based on, randomness or whatever of the ground is hard and the rest of it is fall through. So like you're not stuck. And you can actually people have like just spent days just going through this crazy world where you're just walking through the memory and everything's crazy. And one guy got to the spot in memory where the time was being like, put. And so like as the seconds ticked, like the world shaped in like weird ways. It's really trippy. And so, but the point is like you don't get a crash with like, hey, at this point in your code, something weird happened. You just weird things happen with no way to track them down.
Yeah.
Yeah, so that's my soapbox.
All right, so we're running a little long. So before we keep people past how long they want to listen, let's you want to do a few more weaknesses, or you want to go ahead and move on to tools for working with C++?
Yeah, let's jump to tools.
All right.
I personally really like code blocks. Have you ever used code blocks?
I have not.
So, I do a lot of development on Linux, but there was a time where I was, doing my home development on Linux, but I was doing my work stuff on Windows. Now I happen to actually be on Linux 100%. But at that time, I really wanted something where the same IDE on Windows and Linux. And CodeBlocks does exactly that. It actually works on Mac, Windows, and Linux. It's very consistent. And it does sort of, it's not as nice as Visual Studio, but it does like 99% of what you need and totally
Nice.
cross-platform, yeah. What about you?
Another cross-platform development is Eclipse CDT. We talked about Eclipse, and Eclipse originally came out as Java only, but since then people have added some C functionality in the what's called CDT, C Developer Toolkit. I think that's what it stands for. And so it basically does the same thing for C. It requires some extra setting up and handling, but it works pretty good.
Oh, nice. Yeah, I haven't tried Eclipse on Windows, but I'm sure it's a lot better now. I used a really old version of Eclipse, but I'm sure they've come a long way.
And then aside from just tools to use to write code, I also wanted to talk about Boost, which is a very popular library for C++, which adds a lot of the features that were now added to the new C++ 11, so like shared pointers and stuff, and just a lot of common usages that you might want that instead of having to implement yourself, you can just use the Boost libraries version, and it tends to be very good and well supported.
Yeah, definitely. Yeah, as Patrick mentioned, shared pointers have actually, even though they're just coming into C++ now, they've been in Boost for years and years and years. So you got to be using Boost if you want to get all of the productivity out of your C++.
So C++ is commonly used. We talked about game programming. We didn't really talk about it, but we kind of alluded to it, which is embedded computers. So things that are low power, low memory, things where you want to be able to have tight control on everything that happens. They're used there. Where else are they used, Jason, or is C++ used?
So all web browsers, right? Chrome, Firefox, Internet Explorer, all these are written in C++. Most, huge programs that you can think of are probably written in C++. And that just goes back to our explanation of just how like it's possible to make just gigantic programs and many libraries and all sort of coordinate.
Yeah. So I think that pretty much wraps it up for C++. I wanted to say thank you. A number of people have written in to say how they're glad the show is back. It's been encouraging.
Yeah.
We've had a number of comments and suggestions and that kind of stuff. That's appreciated as well. We're glad to hear from you guys. We enjoy doing this. We're glad that some of you enjoy hearing it.
Yeah, totally. We used to announce programming throwdown at Gmail. It's probably good to mention We don't follow that as much now that we have the Programming Throwdown page on G+. So if you want to write to us, we do follow. Like we check it maybe once a week or something like that. So you can definitely write to us if you have something you don't want to share to the public or something like that. But most of the time, you definitely want to check out the G Plus page. If
Google Plus.
That's right. If you go on Google Plus and you put in Programming Throwdown, it will take you to the Google Plus site for Programming Throwdown. And you can feel free to leave any comments. We post all the show notes there in addition to the blog. So, yeah, definitely
Yeah. All right.
add it to your circles.
Until next time.
See you guys later. The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.